yeah, it's great to be back in cloud coaching session. So thank you for this opportunity. For today, as you mentioned, I prepared the subject of interest with focus on healthcare and how we can innovate using the Oracle AI ML cloud platform. And today I will show you an art of the possible demo, which is inspired by actually by a real case and by stem cell donors. You maybe know that patients with a variety of blood diseases, immune or metabolic diseases may require stem cell transplantation as a treatment. However, according to National Institute of Health in the US, approximately 2/3 of the patients do not have a suitable human. It's called human leukocyte antigen. This is the marker used for donor patient matching. So basically, they don't have a matching donor in their family, and they require an alternative donor. Usually, it's unrelated donor to proceed with the treatment. There are a lot of stem cell registries across the world dedicated to recruiting, finding the healthy and committed volunteer donors for patients in need, and they are typically recruited either online, or there are also stem cell drives where they can go. And recruiters basically what they do is secure the informed consent and guide the registrants forward. So this way, the donor joins the registry, and maybe sometimes in his life, he might get a call to be asked to donate in case he's a match for a patient in need. So, and you might ask, okay, and what is the business case here? Basically, the success of the transplant depends not only on finding genetically matched donors, but also on the donor's availability. And apparently, on average, 50% of the potential donors are unavailable for a variety of reasons after initially matching the patient. They either got married and don't want to donate anymore because they have a family, or they changed location and they are unavailable for traveling, or they might got sick in the meantime and they are not able to donate. So a lot of reasons, and these are just example I've read about. So basically what we want to achieve with this art of the possible demo is to predict the stem cell donors availability based on demographics and non-genetic donor related factors. And we think that this could potentially be used during the donor selection process to help improve the decision and to minimize the risk of delays in transplantation. So that would be in a nutshell. Now, what we will see today is a summary of what we want to achieve, how we can achieve it, and what technology we have used behind the scene. Basically, we target two personas in the business. The physician or the researcher who wants to be able to predict the availability of every registered individual as a donor to be used during the donor selection process. And the data scientist who wants an end-to-end platform to address the data science lifecycle and to help physician selection making process easier with machine learning. And what we want is to give the physician a tool that will allow him or her to understand what are the characteristics of the donor population across the registry, what types of donors we are missing from the registry. Either there are preferred donor characteristics that will give maybe higher transplant success rates, or maybe we have few rare HLA matching donors. And also we want to see what are the areas where we need to conduct public campaigns to educate the people in order to understand the importance of the stem cell donation. Also, it's important to understand the factors that influence a donor's decision to donate and which individuals are most likely to donate when they are a match. So I will switch to my environment to show you how we achieved this. But I just want to explain you the first step, which is we will start in the role of the researcher who has some data set on their on the donors, and she wants to have a high level overview about the donors. Let me switch. So you should see my my environment with a data set. Okay. So basically, I am, as I mentioned, in the role of the researcher, and I'm going to use Oracle Analytics Cloud to demonstrate how we can address the data cleansing, feature engineering, and exploratory analysis stages of the data science lifecycle. I am moreover in a role of citizen data scientist, because I won't be doing the end-to-end cycle. At a certain point, I will probably need to ask the data scientist to intervene. But now I have this table including all stem cell donor data from the donor registry. You can see I have donor age as an information, whether the donor already donated or not, stem cells, so yes or no, whether he owns a property or not, the location he lives in, the distance to the donation center, a lot of other information around the education, whether he's a blood donation reliable donor, the blood type, and a lot of other information. For example, years on the registry. And before I start my exploratory analysis, because it's a great starting point, this data set, I would like to take a look at the dataset editor, where I can assess basically the quality of the data. I can make transformations, I can receive data enrichment recommendations from the engine. So for example, as a preview, I can see at the top the distribution of the values that are in each one of the columns. And I might come across examples where there might be some data quality issues. For example, property owner, I have some missing values. And if I want to, I can use my know-how and business know-how and replace missing values with any value I consider it's suitable. In this case, let's say I replace the missing values with unknown. So it will automatically transform the data for me. I can also use recommendations that were given by the engine. For example, if I click on country, I might want to enrich the country information with ISO2 is just an example. So if I click on that, the tool will automatically add a new column for me with the country ISO. So once I'm happy with the changes, I can save the result and I can go to my workbook to perform exploratory analysis and to get a better understanding of my donors. And I will switch to that so you can see it. Basically, on the top of the dashboard, I see number of donors, the number of donation centers, average years on the registry for my donors, the geographical spread of donor. I can see I have donors across the world, number of donors by blood type and by gender. For example, I see that 0 blood type is quite rare, and I might want to take some actions on this to try to educate the people and get more donors with this blood type. And I can also see the split by gender, where we have more males registered, which is a good thing because studies show that the male donors have a higher transplant success rate. Also, we have quite a small number of donors below 31 years old compared to 31 up to 60 years old, which are where the younger donors are preferred for the higher transplant success rates recorded so far. And so on. So I have a lot of information already, so I can pass my findings to the marketing department to take action and to conduct maybe perhaps a public campaign to educate the population on the importance of donating stem cells and the risks attached to it, in order to get maybe younger donors or low represented geographies registered in our database. Now, switching back a bit to slides. So we did the initial data discovery, and then moving forward, I would like, and it will be very useful for me to be able to predict every donor's availability in order to simplify the donor selection process. And I will ask my data scientist colleague to build a model in order to do that. So I will switch again to the demo environment. This time, as a data scientist, I will want to use Oracle machine learning in order to do the data preparation and the model building. So in the role of the data scientist, I got the request from the researcher to build a machine learning model that will predict the donor's availability to donate. And I am here in Oracle Machine Learning in the database. I will do here all the steps in the data science lifecycle, from data exploration, preparation, up to model building, model evaluating, and model deployment. The notebook you see here is a Zeppelin notebook interface where I can write either SQL, R, or Python code. And the data set already resides in the autonomous database, which is a great thing because I don't need to move the data. Oracle Machine Learning in the database moves the algorithms to the data, and it eliminates the data movement to leverage basically the database parallelism and scalability, and also maintain the data security. So you can see all the tables in my database, and if I look at my table with stem cell donors data, I have 1,470 rows, which would look like this. All the information that I've already presented in Oracle Analytics Cloud with information about my donors. Now, the target column, or the column I want to predict, is the donor answer when it was asked to donate. So I either have yes, I will donate as a value, or no, I won't be able to donate. Basically, it's a binary classification problem that I would want to solve. And moving forward, Oracle Machine Learning allows me to plot visuals very, very easy for data exploration purposes. And I have just 2 examples here to illustrate how we can do that. Basically, we are able to choose between the type of charts we want to plot. And I have here, for example, the address change by the donor answer. And I see some null values here in the address change. Address change meaning the user or the donor registered changed his address after he joined the registry. And because this data set is generated for demo purposes, I don't have actually too many data quality issues. I will just do in this piece of code, I will just replace the missing values and I'm good to go. But in production, you might encounter many other either data quality issues, or you might want to do the feature engineering part. So you can perform here all these steps. You can write code as you need to. Next, I need to build my model. So what I can do here is I can choose between using the Zeppelin notebook environment to write code, or I could use AutoML user interface to start basically experimenting model building in a point-and-click interface. And there will be no coding needed. What I use is what we call experiments, and I have here an experiment already prepared. Let me just show you how I set up this one. So basically what I need to do is just give it a name, select the data source I want to use, and it's all, as I mentioned, the data resides in the autonomous database. I need to select or to specify the column I want to predict. In my case, the donor answer, yes or no, and the prediction type. Because it's a binary classification problem, I just use classification. And also I need to give it the primary key for my table. I can further do some additional settings, like let's say, for example, selecting the maximum number of models to be tested, the execution duration time for my experiment, the model metric that I want to use for model evaluation. And you will only find in the list the specific metrics for the prediction type we choose. And you can also choose the algorithm to be tested and the features to be included in the experiment. Next, you can also see the features that will be used. For example, in my case, I removed the donor age and donor age at registration, as they are highly correlated, and that would negatively impact my prediction. So once I execute this, I will see the progress bar and all the actions that the AutoML does for me. It will automatically do algorithm selection, the adaptive sampling, and feature selection and model tuning. Steps which usually take time in the data science lifecycle. And once this is done, I will see the results on the leaderboard. I will be able to see the accuracy that each of the models return. So for example, in my case, random forest is the top performer. I could also add some other metrics if I want to, or I can exclude them. And if I click on the model name, I can see the feature importance and how the features impact the predictions. So for example, in my case, I see that donor age at transplant request. So what age the donor had when he got a call to be asked to actually donate, and the distance to donor center are the top two features that impact my predictions. I can also see the confusion metrics and basically the actuals versus the predicted values for my for my model. Basically, this illustrates the accuracy that I got. Now, from this point on, if I'm happy with the result, if I'm not happy with the results, let's say, I could rerun the experiment with other settings. And in case I'm happy, I can choose to deploy the model into production. So I just need to give it a name, a URI, and a version. I can click on shared. So when this will be deployed into production, the business users, the model will be able to be registered in Oracle Analytics Cloud, and the business users will be able to basically consume the results. So that would be one option, and I will be able to see in the list of models all the models created and all the models that are deployed into production. Now, if I come back to my experiment, another thing I could do is, let's say I want to maybe use the random forest, which is the top performer in my experiment, and maybe add some more on it, build some more on it. I can just click on create notebook, and it will automatically generate a notebook for me. I will just give it a name, a test. You can give it any name you want, and it will automatically create for me a notebook. As you can see, it's very, very fast, which I can use next. Basically, it's a automatically generated notebook, and what it does, it will get the selected data for me. It will prepare the training data. It will build a model, the top performer which I selected, which is the random forest. It will show me the model details, and then it will score the data. Of course, we can run this. I don't want to necessarily spend time on this, but just to show you how it works. So this is so these experiments are a great starting point for the development phase, and what it actually does, it will shorten the time to the development time because it has this feature selection, algorithm selection, and model tuning, model hyperparameter tuning. So you see it got the data, and then it will prepare the training data and so on. So basically, once the model is in production, I could take these results to the business users. Now, perhaps Violeta, is there any question you want me to answer, or?
Emma, in fact, I do have a question.
Please.
If I may. So,
yes,
why is it important to extend the geography? And I was wondering if, let's presume, a patient from one continent can receive stem cells from another. How does this work?
Okay. So basically, the thing with the geography is that we have genetic diversity, which is created when different populations mix together, which means some ethnicities have a rarer HLA tissue, the marker that is used for donor matching. And this makes it harder for us to find a good match for some patients compared to others, or not for us, for the physicians. And to resolve this problem, they basically need to educate the population, I would say internationally, to add more people from minority ethnic backgrounds, for example, or from regions where there are rare tissue types, to join the stem cell register and to provide a larger pool of potential donors with these diverse tissue types to help all the patients have an equal chance of finding a match.
Thank you. Thank you. You said at the beginning, when you talked about the demo inspiration, that the matching percentage in the families is really low. Do you know why it's so low?
Yeah, so these HLA types, this marker used to match the donor with the patient, these are inherited from the family. So siblings, but not that often as we might think. So siblings can only sometimes be a match for each other, and the statistics say that each of the patient's brothers and sisters who has the same mom and dad has a 1 in 4 chance, which means 25% chance of being a full match. So yeah, that's 25% chance if you are in the family. Full match means you have all the HLA types needed to be a match. There can be partial match, but that would, or the full match would give better outcomes for the patient when doing the transplant. So basically only 25% chances to find a match in the family, and for all the other patients they need to find an unrelated donor.
All right. Thanks, Emma.
Thank you. Sorry, was there another question or is it just this one?
No, I think that's all. We are answering them as they come on Q&A, Emma.
That's great. That's great. So then let me move forward. So after we have done the model building, I will be back in the Oracle Analytics Cloud, and let me switch the environment. So I am back in the Oracle Analytics Cloud in the role of the researcher or the physician, and the data scientist has already built the model for me. Now, the machine learning model can be integrated with Oracle Analytics Cloud, as I was saying. In my case, it was already registered. I registered before when building the model. So it needs to be registered once. That's a one-time operation. And once this is done, I can use Oracle Analytics Cloud data flow that you see here. Basically, it's a user-friendly interface that allows me to apply the machine learning model to my data set. So basically, I load my data. It's like a flow made of different steps. So I load my data set, my new data set. I apply my model to it. I can do here some settings, and then what I need to do is save the data. Now, once I execute this, I will have the results saved and available for me to use them. And let's see how this looks like in terms of dashboard results. So let me switch again. So okay. So I have here a dashboard that will illustrate all the results from my model, right? From my predictions. And I have created various visualizations to look at it for me because I'm in the role of the physician or the researcher, to be able to actually read the results, because I'm not familiar with model building and the data science part. So the data scientist sent me this model, and I want to be able to interpret it in terms of business and with my own language. So I have here a list of donors and the prediction made by the model and the prediction probability. So for example, for donor ID1, the model predicted he will answer no, I won't donate when he will be called to donate, and the probability or the confidence of the model for the prediction made is 75%. So let's say I have a patient that needs a transplant, and I have found 3 matching donors. Let's say ID 1, 2, and 3. How I can use this list? I can filter the table and take an immediate action to actually first contact the matching donors who are predicted yes with a high probability to be available. So out of my donors, 1, 2, and 3, only the third donor was predicted to say yes. So I might want to first contact him. And hopefully this will shorten the time to transplant. Next, let's see what characteristics influence the decision to donate of a donor. So looking at how the data is distributed, I see almost 3% of the donors in my data set predicted to respond positive in an immediate call for a donation. So people aged, for example, where is it here? 16 to 26, I would say, would request, would answer yes to the request of donating, which is a good thing, as the age of the stem cell donor is one of the most important characteristics that would influence the stem cell transplant success rates. And the younger donors are associated with better survival rates. Also, we can see here that people which are closer to the donation center tend to respond yes when they are asked to donate, while the ones that are far from the donation center would tend to say no. At least that's what my model predicted. And I can also see the availability by education. The ones who would say yes would be with higher education degrees. And then another example of how I could use it, it's, let's say we run this model monthly. For example, donor 1 or donor 3, it's a yes donor this month, but next month he might be a no, or he is a no, because he might be change his address, for example, from far from the donation center, or he is older and not willing to donate anymore, or we may come back to the prediction and say let's call the no donors to cross-check and make sure, like, you know, like a regular check, if donor X is still okay to donate if needed. And for example, if I select on no, actually not the donor ID, I just wanted to okay, let's say we only have the no's in here. I filter to for the prediction with no, and basically I can look at them and I could call them and check Okay. And another way I can use this prediction dashboard is to look at donors that have rare human leukocyte antigen tissue types. That would make us harder for us to find a good match for some patients compared to others. And again, to solve this problem, we can contact the no donors that have a rare HLA matching. For example, I might filter by donor type equals 0, blood type, which we know is a rarer blood type, and we see them on the list, and we want to contact them to make sure if those donors are still willing to donate or not. This way we have a list of donors that are reliable for us. So that would end the demo for me. And let me go back to the slides and basically share with you what we have done in terms of what we have used behind the scenes. So basically you have seen how the physician is now able to have a look over the donor's data and understand what's in that data set, and then easier maybe find a matching donor for the patients. And the data scientist who has the environment, the end-to-end platform to do the data science requirements. And in terms of the technology used, we have used the Oracle Analytics Cloud for exploratory analysis, bit of the data preparation part, which was used for dashboard creation, and then the business insights. Then we have used Oracle machine learning for the data science part. We have used AutoML in order to speed up the model building and to be able to experiment with multiple models at the same time. And also Oracle Autonomous Data Warehouse for data persistence. Now, I just want to mention one thing before ending the session, is the fact that we basically use the synthetic data generation. The data set you have seen is not real data, because it's about patient records and patient data, so we didn't want to expose that. So we have generated synthetic data using generative AI methods. So with that, I conclude
a quick question, and you kind of mentioned this. What if you wanted to push it further to another group, like end users? Is that possible?
Yeah. So basically, any user that is able to do, any user that has access to Oracle Analytics Cloud is able to consume the model built in Oracle machine learning in the database. The model needs to be registered just once, and all the users that have access to it, to Oracle Analytics Cloud, can consume the results. They can create that data flow that I showed, and then get in new data and score it using the machine learning model. And it's really nice the fact that basically they can become citizen data scientists, and they can, if they have advanced statistics knowledge, they are able to do it this way.
Cool, thanks.
Yeah. Thank you. Let me know if there are any other questions.
And Valentin and Bob have been answering someone on chat and on Q&A, but I think we're actually okay. So.
Okay, that's great. I don't know if I mentioned, maybe some of you might be wondering. That's a question I actually got often when talking about this demo. I was asked who can join the stem cell registry, and I think that's an important thing to mention, because it's a thing that relates to the society in general. So I think that's good to share. So basically, anyone aged between 16 or 17 years old as a minimum age, up to 55 or 60. Also depending on local legislation, especially for the younger donors. So anyone can join the registry, and they need to be in general good health, and there are even some health conditions accepted, but you won't be able to register if you have any severe disease, heart disease or lung or kidney disease, or severe illness of the central nervous systems. Other than that, everyone is welcome to join, and maybe at a certain point in life they might donate to for a patient who is in need.
There's a question by George in chat, probably worth mentioning. Have you used other Oracle software?
Sorry, can you repeat the question, Tom?
Have you used other Oracle software? So in the demo, is there anything else, Emma, that you've used other than machine learning? Anything else that you've used?
So I've only used the Oracle cloud infrastructure, and you've seen Oracle Analytics Cloud, moreover, for data visualization, Oracle Machine Learning for the data science part, and autonomous database for storing the data in the database. So for the data science part, I only used autonomous Oracle Machine Learning. I've only showed you parts of it because we didn't have time to go through everything. But basically, you've seen that you have the possibility to experiment, to do AutoML experiments, and shorten the time to good results and to picking up the best performing model. And you can combine that with writing Python code in the Zeppelin notebook, either Python code or R code or SQL, or a mix of them, depending on your preferences. You could also use the explainability features that we have, because it's a healthcare type of scenario, and I actually got this question as well, okay, because it's healthcare. How do you sometimes the machine learning models are a black box, and you can't necessarily explain why a certain prediction was made. But using the explainability functionalities in Oracle Machine Learning, you can understand why a certain prediction was made.
Okay, I think George is happy as well, so yeah. He's cool. Thanks, Emma.
Thank you, Tom. And thank you, George, for the question. So I guess if no other questions, I can stop here. Violeta, do you want to share anything else?
If no further questions, I would like to thank you all for joining us today. Thank you, Emma, for delivering for us this morning. It was great, and of course to have you back at Cloud Coaching. We are waiting to having you as well, delivering other sessions soon. We hope that you guys enjoy it, and we hope to see you soon in our sessions. Thank you. Enjoy the rest of the day, and stay safe. Bye bye.